Hello everybody. In this video, I will be explaining to you about a topic which demands attention. If you like my video, then don't hesitate to hit the like button. It has been the envy of many a planet, a unique feature that sets the Earth apart from the rest. It is a sustainer of life on Earth. It gives a theme to our Earth. Yes, Hydrosphere. As we've already seen in my previous episodes on endogenetic processes, the Earth is a conglomerate of various spheres such as the lithosphere, hydrosphere, atmosphere, and the biosphere. Here we will see about the hydrosphere. The Earth is surrounded mostly by water, while the remaining 29% is covered by land. Since a large portion of Earth is covered by water, when viewed from outer space, Earth appears bluish in color. The Earth's water is not static. It is in continuous motion. This continuous movement of water on the surface, above the surface, and below the surface is referred to as the hydrological cycle. This occurs through three major processes, namely evaporation, condensation, and precipitation. This process can be demonstrated like this. We all know when water is heated, it evaporates. This vapor, when it comes into contact with the cold surrounding, condenses to form water droplets. These water droplets falling to the ground is called precipitation. Based on the amount of salt content, water can be classified into fresh water and salt water. Of the Earth's total waters, only a mere 3% is fresh water, whereas the remaining is salt water found in the oceans. And of the 3% fresh water, a major part of it is locked in the glaciers. Only a meager 1% is found in the rivers and lakes. Next, how are land and water distributed on our planet? Northern hemisphere holds most of the land, whereas the southern hemisphere holds most of the oceans. Hence, they are referred to as land hemisphere and water hemisphere respectively. In one of my videos on gradation, we come across the various landforms found on land. Now here we will see the various landforms found under the oceans. Relief of the ocean floor. The outer layer of the earth we call crust. In the crust, the areas with high ground we call continents, and the ones with the depression is referred to as oceans, seas, etc. In the oceans, the areas close to land is called the continental shelf, just like the shelf at home. Since it is not very deep, sunlight penetrates the water and sustains planktons and other living things. Next to it, we see the continental slope. Having a sloping feature, it is free of sediments. This region forms the boundary between a continent and an ocean. At the bottom in mid-ocean, fine sediments of sand is found called the abyssal plains. Sunlight could not penetrate to such depths, and so no life is found in this region. What is a mountain range doing here? Well, if the mountain range is found under the water, it is called an oceanic ridge. The deepest part of the ocean is called a trench. They are V-shaped and the epicenter of great earthquakes. Well, how do oceanic ridges and oceanic deeps form? Under the ocean floor, when the tectonic plates move apart from each other, the molten magma under the crust spills out onto the ocean floor, forming a narrow mountain-like ridge called an oceanic ridge. Whereas when the tectonic plates converge, one plate tends to go under the other, creating a depression along the seabed called an oceanic trench. A visual recap of the major relief features of the oceans. Here I will demonstrate why oceans are salty. Take a beaker of fresh water. Add a portion of salt. Now boil the beaker of water. What happens? The water evaporates while the dissolved salts remain. When the process is repeated again and again, the waters evaporate while the salts accumulate. The same process happens in our oceans too. The rivers dissolve the salts present on land and deposit them in the oceans. Imagine this process repeating itself for millions and millions of years. Hence, ocean waters are salty. Somebody is sailing. Next, we will try to understand the various movements of the ocean waters. Ocean waters is dynamic, which means it doesn't stay static or stay in one place. Ocean waters move both horizontally and vertically. Some of the factors that determine the movement of ocean waters are temperature, how hot the waters are, salinity, the amount of salt content, thirdly, forces of the sun, moon and wind, about which we will see in this video. The movement of ocean waters can be classified into three types. They are waves, currents and tides. First, waves. Waves are ripples on water caused by winds. Currents. The movement of ocean water on the surface and at the depths of oceans in a definite direction, which is usually horizontal, is called ocean currents. Thirdly, tides. The vertical movement of ocean waters due to the gravitational pull of the sun and moon is called tides. Tides can be classified into two, one spring tide, another neap tide. We know that a large part of the earth is enveloped by water and that the sun and moon exert a pull on these waters resulting in tides. When the sun, moon and earth are in a straight line, their combined pull cause the earth's water to spring high. Such tides are called spring tides. When the sun and the moon are at right angles, their pull works against each other, resulting in low tides called neap tides. Yes, how could I tell which tide is what? Well, here is a clue. Spring tides always occur on full moon days and new moon days, whereas the neap tide occurs in between two spring tides, that is during the first and last quarter moons. Ha! A challenge between the sun and the moon. The moon's gravitational pull on the tides is much greater than the sun's. Distance matters. Next, we will try to understand current movements. When you heat a beaker of water, the water molecules at the bottom gets heated, becomes less dense, so floats upwards. When you heat a beaker of water from top, The water molecules have no place to go further upward, rather they move sidewards or horizontally. This is how ocean currents move. The heat from the sun and the heat that gets transferred from the land is a major cause for surface currents. Besides the sun, the earth's rotation, the prevailing winds too influence ocean currents. And the less conspicuous is the volcanic activity under the ocean floor. It too determines deep ocean currents. Ocean currents can be identified as warm currents and cold currents. Major currents of the world. In this map of the world, you could see all the major oceanic currents. Take the Atlantic currents. You could see that the warm currents shown in red moves away from the tropics, and the cold currents shown in blue moves towards the tropics. In the southern hemisphere too, the same thing happens, only that their direction has changed. The following visual will explain better. From the tropical regions, which is shown in red, the warm waters move to the temperate regions, and the cold waters from the temperate regions, which is shown in blue, move towards the tropics. This phenomenon occurs in both the hemispheres. The exception is that the waters move clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. The mighty oceans hold a treasure of resources, and they can be broadly classified into biotic and abiotic. All the living things found in the oceans are generally termed as biotics. Besides the biotic things, other things or the aspects found in the oceans are the abiotic things. Okay, how specifically are oceans useful to man? Here are some of the resources found in the oceans. If the oceans are so useful to man, then is it the way to treat them? No. Then how can we conserve the earth's waters? As children, we can simply do one thing. Don't dump waste in the water bodies. Water. Without water, where will we be? Is it not our duty to conserve water, the most indispensable natural resource on earth?